Now we're going to look at problem 7. In this problem, I will actually just describe what the template does, and I want you to go ahead and try to fill it in with the appropriate functions, and also go ahead and create the model on Solver platform on your own. On the solution tab, you will see the final solution, but I like you to work on this on your own. So let's first look at what the problem is asking us. You have a company that produces electronic and battery operated smoke detectors, and these are produced by going through 3 different operations: fabrication, assembly, and shipping. And there's a certain demand for the electronic smoke detectors, and there's a certain demand for the battery operated ones, and the total demand they may or may not be able to satisfy using their current resources. And if they can't, there's an option of subcontracting additional units from an outside source. And also perhaps it might be more profitable to subcontract it, but then when you look at the profit numbers, it's much better to make it yourself than subcontracting outside. So as you can imagine, the particular solution will never suggest you to outsource anything unless you don't have the resources for it, because it's definitely more profitable to make it yourself. So again, the worksheet has 3 modules: decisions, the objective, the constraints. We have 4 decisions: how many electronic smoke detectors we'll produce, how many battery operated ones we'll produce, and how many of each we will buy from the subcontractor. Our objective function is maximizing profit, and the revenue and the cost figures are given for all options. Then we have 6 constraints. How much fabrication time do we have available? How much assembly time do we have available? How much shipping time? How much shipping time do we have available? What is the total demand for electronic smoke detectors? What is the total demand for battery operated ones? And how much can we subcontract? So in this template, before you set up Solver, all you have to do is fill in column F, a formula for the profit and a formula for the left hand side of each constraint. And then once you do that, you can actually try out different solutions and see how things work out. When you enter your formulas, then you're ready to go to the Solver platform ribbon and click on the model dialog box, and then add your objective function, your decision variables, and your constraints. I will leave it up to you. Now, assuming that you have gone through all the steps and optimized the problem, here's the solution you get. Let's see if the solution makes sense. Very quickly, it looks like you're making a lot of battery operated smoke detectors, which has the highest profit, which makes sense. Then you're making some electronic ones internally, but I think when you make these 2, then you're using up all your fabrication hours, so you can't do any more, which means you're now going to subcontract. Well, also, as you can see, it's cheaper to subcontract the electronic ones. That's probably why you're making the battery operated ones internally. So we're making the battery operated ones internally because it's more profitable, and also it's the least profitable to buy them from outside. And for the electronic ones, some are made internally as much as the fabrication allows us to, and then some are purchased externally. As you can see, we are trying to satisfy the demand as much as we can, because the more you sell, the more profit you'll make. We are not using all the subcontracting limit because we don't have to satisfy the demand. And when you look at fabrication, assembly, and shipping, we are only using fabrication to the limit. So if somebody comes up and suggests to give you more assembly hours or more shipping hours, you don't really need those. But if somebody asks you how much would you be willing to pay for more fabrication hours, that is an interesting question. To see that, we can actually do a sensitivity analysis. Let's go ahead and try to do that. I'm going to define this as a parameter and change it from 2000 to 2500 with increases of, let's say, 50 hours. So I go to parameters, I go to optimization. I'm going to make this start at 2000, go up to 2500, the base case being 2000. Now I'm going to optimize the problem with different values here. So here's what I do. Go to reports, go to optimization. Under optimization, I choose parameter analysis. Well, it asks me, what do you want to observe? Well, I'd like to observe the variables, what happens to my decisions, and the objectives. So I'm just going to choose all. And then which parameter do you want to change? Well, I only have one parameter in the spreadsheet, which is H13. I choose that. And then it says how many major access points you have, basically from 2000 to 2500, how many values do you want to see. If you choose 11, then you will increase it by 50 each time, because 11 major access points means you have 10 divisions between 2000 and 2500. So I'm going to increase the assembly hours. So I'm going to increase the fabrication hours available by 50 units each time. I hit OK. As you can see, it quickly runs 11 optimization models. You can see that as I have more and more hours available for fabrication, the pattern of the solution doesn't really change. I still make battery operated smoke detectors internally, and this is my limit anyways. It's not like I'm going to make more of them because there is no demand. But as the fabrication hours available changes, I will increase how much of them I can make internally and how much of them I make externally. And it makes sense that since this is more profitable than this, which means making the electronic detectors internally is more profitable than doing it externally. If I have more hours available, I'm making more and more of them internally and buying it less from external resources. To get more familiar with parametric analysis, I recommend that you try out different scenarios and see how things will work out on your own.